Good evening, everyone. Beautiful evening to everyone. Yeah, you're welcome, guys. Welcome. Yeah, welcome, Johnson. You're welcome. Simi, you're welcome. Hatom, you're welcome. Praise, you're welcome. Precious, Alex, you're welcome. Welcome, guys. Powerfully welcome. So tonight's class is going to be really great. Yeah, you're welcome, Timothy. You're welcome. Elendo, you're welcome. Larry, you're welcome. Tempest, you're welcome. Taiwo, guys, you're really welcome to tonight's class. Going to be really great. This is a very beautiful topic. It's one of the topics that some students find difficult, although I find it very interesting, very, very lovely. One of the topics that are this is quite very practical, realistic. And also I want you to understand that this is the basics for so many things you'll be doing in statistics generally. You need to understand probability very well if you're going to do really great with statistics. We're going to be introducing probability in tonight's class, and I really promise you would really understand it at the end of this class, because I plan to divide everything in bits for everyone to be really able to comprehend everything around probability. Nobody will be left out in tonight's class. So let's get right into it. I'm sure you're ready for tonight's class, and once again, I welcome everyone. We have a lot of great things to do in tonight's class. So yeah, let's get right into it. Are you guys ready? Can we go on? Good. I love that. Yeah, I can see you guys are ready. That's nice. All right. So without wasting time, let's get right into it. So what is probability? If you hear the word probability, what comes to mind first? You need to understand that probability comes with the word probable. Probable. That means it's not certain. All right. It's not certain. So we can talk about probability as a branch of mathematics that deals with random experiments. And what does the word random comes to mind when you say random? Random is something that happens by chance. I love what Taiwo just said right there. Chance. It's by chance. Random experiments are by chance. You have no certainty of them happening. So you cannot say, if you toss a dice, for instance, you cannot say, I toss a dice. Let's take, for instance, one very common example, or some people call it die. Anyway, so if you see, for instance, you tossing a die, I'm sure many of you are very used to playing Ludo, the Ludo game. If you toss a die, you cannot ascertain the chance that you're going to get a 4. You cannot say, well, I'm going to toss this die 10 times, I'm going to get a 4 10 times. No, that's a very great definition of the word random experiment. It's by chance. You do not have certainty of anything happening. Now, look at another example when we talk about random experiment. We talk about a coin. A coin. A coin has two two sides of it. You have one place we call the head, another place we call the tail. Now, when you toss a coin up, you do not have any certainty that you're going to get a head or a tail. So it's possible you get a head, it's possible you get a tail. Yeah, I love the example I see Taiwo giving again. A card, like cards, rather. So I'm sure I will talk a bit in depth about cards, because I'm sure not everyone is very used to playing cards. And it's one of the questions that used to come out. And if you don't understand the experiment, it is hard for you to solve questions on them. And because, no, we're talking of not ATM card, we're talking about playing cards. Like when you play, we have the ace, we have the jack, we have spades, we have diamond. I'm talking about the pack of cards that you play. Now, when you play cards, some of you are very used to cards, some of you are not. So I'm going to go on to talk about cards in a moment. Now, when you see everything we just talked about, this is all under probability. You don't know if you're going to, when you are shuffling a card, you do not know what is going to be the outcome of the first one you pick. You do not know if you're going to pick a 2, or you're going to pick a jack, or you're going to pick a king. You do not know the outcome of that pick after shuffling. That's all random experiment. Now, this is a branch of mathematics that we deal with, and it's very, very interesting. I want you guys to settle your mind. You're going to understand it very much. It's very, very interesting, very, very practical. It has several questions that can be administered because of the level of practicality. It's everywhere. You can get questions from several events. So let's now talk about, let's bring it to definitions properly. I say probability measures the likelihood of an event occurring. It measures the probability of an event occurring, the likelihood. That means, what's the probability that when I toss a coin, what's the probability I'm going to get a head? Those are the kind of questions you should be getting. What's the probability that when I toss a coin 2 times, what's the probability of getting a head the first time, a tail the second time? So I toss a coin up 2 times now. What's the probability I'm going to have a head the first time, a tail the second time? Also, for instance, what's the probability that if I toss a die up 2 times, what's the probability that the sum of what I get will equals to 10? So let's say for you to get the sum equaling 10, we probably get a 4 the first time, we probably get a 6 the second time. This is, and the sum of this will give you a 10. It's also possible you get a 5 the first time, you get a 5 the second time. This will obviously give you a 10. These are the kind of questions you get to see in your exam that you need to be very versatile in. So now, before getting into so many examples in terms of solving, I want you to get familiarized with how to solve, how to identify what we call the sample space and the event space in probability. Those are two very key things. Let me tell you this. As a student, if you are able to identify the sample space and the event space, that's all you need. You can never miss any question. So that means I need to spend a little bit of time in teaching you how to identify these two important things in probability. Before we get into event space and sample space, let's talk about the general formula around probability. I'm sure you have seen this probably somewhere. When you talk of probability, we always say it's the number of expected outcome. Some people call it favorable outcome divided by the total number of possible outcome. Now, this is the general formula you would always see out there. If you look at this formula, it's more like saying you have an event. Let me just use this let me use the random one we just mentioned. We mentioned a coin now, for instance. If I throw a coin up, what is the total number of possible outcome if I'm doing an experiment that has to do with a coin? Of course, the total number of possible outcomes there is 2 because I can either have a head or a tail. So that means this will be obviously, if I'm dealing with a coin experiment, I'll be dividing over 2 because that's the total number of possible outcomes. Now, if I was expecting a head, that means if the experiment said what is the probability of you getting a head? That means you were expecting a head. In that case, what's the total number of that expected outcome? Tossing a coin up, what's the total number of having a head? Of course, just one, because you only have one head. You have one head, you have one tail. So obviously, the probability of you getting a head will be 1 over 2. That's a very simple example. Of course, that's not the way every question will always come. Not as simple as that. But that's a basic example you can always relate to understand this formula. Now, another better way of seeing the formula is seeing it like this. N into bracket E over N into bracket S. Now, I'm sure everyone here is familiar with set theory, and you understand what we call sets and subsets. Now, I'm sure you also understand what we just wrote right here when we said N into bracket E. This, obviously, this nomenclature, this notation is what we use to talk about the number of elements in that set E. So that means what you see right here is that there's a set E. Of course, E here stands for event. And then there's another set S. S here stands for the sample space. So we talk about the event space, we talk about the sample space. So the numerator obviously is telling you to insert into that spot the number of elements in the event space. I told you guys already that you need to always be able to identify the event space in any experiment and also identify the sample space. Once you can do that, all you need to do is go on to count the number of elements in the event space. For instance, let's talk about the coin experiment we just discussed. If I was going to talk about the sample space, of course, I'm okay with writing it as just S, as it's written right here. The sample space, this is going to be the set. Look at it. We have head and we have tail. This is the sample space. I'm sure you can see this is a set that contains two elements, head and tail, because that's the sample space of the experiment of tossing a coin. Now, I could also now define this event space is always depending on the question you are asked. Event space is not always the same, because it's possible that question number here says for you to find the possibility or the probability of having an event happening, and question number B may talk about the probability of you getting another event, a different event happening. So event space is not always rigid. It always comes with whatever question you are asked. Sample space, it's always rigid. The sample space of you tossing a coin will always be this, anywhere, anytime. Now, but you may be asked to define the event space of probably having a head. So in that case, I can say event space 1. I'm using 1 because I can have other events. I will tell you about the other event I can have. Event space E1, I can say of having a head. In that case, if I look at right here, I only have one head. So I can only have that event of one head happening. I cannot have more than one head happening. So this is it. If I now wanted to apply this formula, I need to go on and say, what is NS? What's the number of elements in the sample space S? This is obviously 2. All right. For this particular event of seeing a head, what is the number of elements in this event space 1? Of course, the answer is 1. Or you can see this is just one element there. Now, let me pick and give you another event that can possibly happen. We can have another event space E2, and you could be asked that what was the possibility of you having a tail? In that case, I go on to say there's just only one tail. Of course, let me tell you, not all experiment is always like this. Some experiment you may have more than one tail. Of course, this experiment you only have one tail. In the event of this one tail, of course, the number of elements there, E2, is also 1. Now, if I am asked, I say, and let's say for instance, they ask me, what is the probability of having a tail? Now I know I'm applying this formula. That will be obviously NE2 over NS, because I'm dealing with event 2 here. Of course, you can change this to event 1, event 2, and whatsoever you deem fit. Now, in this case, that will be what? 1 over S is what? 2. Number of elements in NS is 2. This is the probability of having, obviously, a tail. Now, this is nice. I'm sure you guys really, really understand this, don't you? Right? You do. That's great. Now, this is one thing I'm going to now go into now. I want to talk greatly about event space and sample space. This is going to be a very interactive class. So I would really love you to interact with me in the comment section. I will talk about different events, different experiments, and you'll be shooting back at me whatever the sample space should be and whatever the event space will be. Are you guys ready? Give me type ready in the comment section if you are really ready. Tell me you are ready. Okay, now, good. I love that. Look at something. If you're writing something down there, please write this down. Sample space is the set of all possible outcomes of any random experiment. Sample space is the set of all possible outcomes of any random experiment. Sample space is the set of all possible outcome of any random experiment. It is denoted as capital letter S. It is denoted as capital letter S. And then you go on to write number of sample space is denoted as what I wrote here, N into bracket S. That's nice. Now, you can go on to also define event space. Event space is a subset of the sample space. If you have a note there, please underline that. It's a subset. Now, this means that every event space you are going to be listing must be a subset of the sample space. I'm going to talk about something very soon. Let me leave that, what I wanted to say. I'll talk about it very soon. But right, event space is the subset of the sample space, which may be a collection of outcomes of a random experiment. Is a subset of the sample space, which may be a collection of outcomes of a random experiment. It is denoted as E, and the number of outcomes is what you have here, N into bracket E. Yeah, that's great. Now, we want to go into, I will mention an experiment. I'll mention about a few experiments. I want you guys to tell me what their event space is and what their sample space are. Okay, good. Now, let's start from the one I just mentioned. Just type in the comment section quickly. Tossing a coin once. Tossing a coin once. What's the sample space going to look like? Tossing a coin once. I specifically said once because it's a different thing when you toss it twice. Tossing, no, I didn't tell you to tell me the number of elements in the sample space. I said you should identify the sample space. I'm not very interested in the number. The sample space is not 2, by the way. Number of elements is 2. What else? The sample space is not 2. The sample space is not 1. This is what I want you to do for me. Just write S, H, T. That's just it. This is the sample space. This is the sample space, not 2. What you guys are writing, or some of you guys are writing, is this. And I don't want you to get into this yet. This is easy. This is where it all starts from. Once you identify this, I'm sure every one of you can count elements in a set. But if you cannot identify the set, you won't be able to identify this. All right? Thank you. I can see the answers coming up. Good. Okay? Now, I want you to now tell me the event space of getting ahead. The event space of getting ahead. The event space now of getting ahead. Of course, I know I did this already in a few minutes, so I just want that to be like the very first start. Oh yeah, go on. What's the event space of getting ahead? Oh, I didn't say the event space of getting ahead. Okay, good. I think I just saw the answer. The event space is obviously E being equals to H. This is the event space. because you only have one head possible. That's great. Can you go on to give me the event space of getting a tail? What's going to be? Event space of getting a tail will be what? The event space of getting a tail will be what? A tail. Okay. The event space of getting a tail will be E being equals to what? Just T. Now, I'm sure you guys can do your counting now. So if you're going on to find the number of elements of your sample space, you can identify that as 2. Number of elements in the event space, the first one, you can identify that as 1. Number of elements in the event space 2, identify that as 1. It becomes very easy once you get your event space. Now let's go on. Rolling a die once. Rolling a die once. Can you guys give me the sample space of rolling a die once? And I'm sure you guys can understand the importance of understanding this experiment normally, because if you don't know what a die is now, for instance, you will not be able to even bring out the sample space or the event space. Rolling a die once, good. What's going to be the sample space? Sample space, I said, not any other thing. Sample space. What's going to be the sample space of rolling a die once? Good. Good. I see the answer there. So for rolling a die once, this is going to be the sample space. 1, 2, 3, 4, 5, 6. If you wrote 7 there, then obviously you don't know the experiment of rolling a die once. This is the experiment. If you roll a die once, this is what is the total number of possible outcomes. That means these are all the possibilities when you roll a die. Now, guys, give me the event space. I will see who is going to get this. Give me the event space of an even number. Give me the event space of an even number. Give me the event space of an even number. Event space of an even number. Event space of an even number. Okay, this is, you see, I could see some correct answers. I could see one being wrong. I didn't, oh, somebody has gotten it wrong now. Somebody's writing 3/6. Of course, that's not correct. Yeah, okay. The event space of an even number, this is it. Look at this now. What are the possible elements? What are the elements when you are talking about the even number of an even number? Look at the samples. I told you already that event space is a subset of the sample space. So your event now of getting an even number must come from your sample space. That means you have 2, you have 4, and you have 6. This is the event space of an even number. All right? Of an even number. Now, what is the event space of getting a 7? Guys, what's the event space of getting a 7? What's the event space of getting a 7? Give me your answer quickly. The event space of getting a 7. Okay. I use this to test if you guys are really flowing with me. Thank you. I can see one person that got it right in terms of the way he wrote it, and that's Omojola right there. If you are asked to give me the event space of getting a 7, guys, that event is an empty set. An empty set. An empty set. It's an empty set because you do not have that event happening. And that tells you one thing. Now, I want to use this to break quickly into a very important part of probability. If I tell you what's the probability of you getting a 7 when you roll a die, of course, you do not need to do so much thinking on that. The probability of that happening is 0. You say, how is that possible? Good. I told you already that probability is NE over NS. Now, what's the number of elements in this set of this event now of getting a 7? Of course, the number here is 0. Yes or no? Because you cannot count any element there. That's 0. Now, the number of elements in the sample space is obviously 6, right? NS here is 6. Good. If you use this formula, probability of getting a 7 will obviously be 0 over 6, which is what? 0. Now, you do not even need to make so much calculations. You do not have a 7 in a die. It's not one of the numbers that you get on a die. So if you are told to find the probability of getting a 7, that's 0. Now, this brings me to something I want to quickly explain. Probability has values between 0 and 1. I want you to note that. Your values of probability must never be beneath this or above this. If you get any value as your answer that is 1 point something or 2 point something, anything more than 1, already know you are wrong in that solution. Your answer for every probability must be between 0 and 1. It can be 0, it can be 1. Now, what does 0 mean in probability? What does 0 mean in probability? 0 mean impossible. All right? If you are taking a note there, please take it well. Impossible. Never going to happen. The probability of you getting a 7 now in throwing a die up is 0. Impossible. That's the meaning of you getting a 0 there. Now, there's another probability that is also possible for you to see is for you to get a 1. If you get a 1, what does it mean to get a 1? Getting a 1 means certain. Certain. This means if you get an answer to be 1, of course, that tells you already that that probability is certain. It's not under questioning. It's going to happen. All right. I don't know. Can anybody right there list any event that you know with a probability of 1? Can anybody right there in the comment section? Can you think creatively and give me an experiment that you know the event of something happening is 1? Anything? You know, it's a very rare event. It's a very rare event because I don't know how many things you are very sure of. A lot of things in this life presently are probable. It's all probable. You don't know what happens tomorrow. You don't know what happens the next minute. So do you know anybody in the chat with any experiment that you can call? Somebody said Nigeria winning World Cup. Sun will shine tomorrow morning. Are you very sure? Oh, somebody went spiritual. Okay. Somebody said I'm going to make it. Okay. Okay. That's all. That's obviously. Okay. Who told you 50% of people will pass Japan? Okay. Arsenal not winning UCL. Ha! Are you kidding? That's so bad. That's an insult on Arsenal fans. Okay. Arsenal not winning UCL may actually not be a good one. Anyone with any, I've not seen any. Okay, probably I saw a spiritual one. Probability of you getting a 16 points. You're sure it's 1? It's not with 4 when you throw it up. Thank you. The law of gravity. That's a very good one. I like that one. Brazil, you guys are being very hilarious there. Okay. Spiritual ones are there again. I can see a spiritual person there. Anyway, good of you. You understand the whole concept. That's a certain event. Now, do not forget, you must get an answer between 0 and 1. Anything below this, you are wrong. I'm not saying it's not possible for you to ever get any answer in probability below 0. And it's not possible for you to get an answer above 1. Please note that. All right? Good. Now, let's go on to in what the experiment we are talking about. We're still on this issue of a die. Guys, give me the event space quickly of you getting a number above 5, a number greater than 5. Sorry, a number greater than 4. A number greater than 4. A number greater than 4. Can you give me the event space of a number greater than 4? The event space of a number greater than 4. The event space. I want you guys to be so versatile in being able to bring out this event. The event space. Somebody's writing E2. No, I didn't tell you to talk about the number of elements in the event space. I'm telling you to give me the event space. The event space. The event space. The event space is what I asked for. All right. This is the event space for those of you following. The event space of getting a number greater than 4 when you have a die. The event space is this 5 and 6. These are the two numbers in the sample space that is greater than 4, 5 and 6. So you guys should understand how to always bring out event spaces and also the sample space. Now, imagine I ask you a question and I say, what is the probability of you getting a number greater than 4? Guys, are you seeing how easy it gets? What is the probability of you getting a number greater than 4? Don't you see the answer right in front of you? That's why I told you the first thing you need to note how to always do, bring out your sample space and your event space. So if I say what's probability of you getting a number greater than 4, all you need to do is, since this is the event space of a number greater than 4, you need to go on to find the number. That's obviously 2. Find the number of this. That's obviously 6. And that will be what? Using this formula, 2/6. That's 1/3. Simple. Are you seeing how interesting probability is? So the main key, which many students always have issues with, is securing the event space and the sample space. And that's why I want us to do a little bit on that before we start to solve questions. Once we're able to get this, we are done. I'm telling you. So let's talk now. I want to save this experiment for some minutes in front of us. I don't want to say this next one, but one of the next experiments I wanted to talk about was tossing 2 coins. But we'll talk about that very soon. Then also tossing 2 dice. We'll talk about that also very soon. Now, but let's go to a much more simpler one. All right. Picking a day of the week. Guys, picking a day of the week. Look at this random experiment. Picking a day of the week. Picking a day of the week. That's a random experiment. Picking a day of the week. Now, I ask you to pick a day of the week. Can you give me the sample space for picking a day of the week? Anybody give me the sample space of picking a day of the week? The sample space of picking a day of the week. Please, I permit you to use just alphabets to represent them. You don't have to write them in full. Picking a day of the week. You guys are still, I don't like those of you that are writing 1/7. That's not the question. The question is the sample space that is associated with picking a day of the week. I didn't ask you to give any probability yet. Just give me the sample space associated with picking a day of the week. The sample space associated with that, the sample space, let's call it S obviously, is just this: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. That's it. That's just it. We told you already that sample space is the set of all possible outcomes. So when I say picking a day of the week, okay, what's the possible outcomes of days of the week? This is it right here. This is the sample space. So if I now tell you to give me the number of elements of the sample space, then you go on to count the number of elements here, which will obviously be 7. But the first important thing is for you to be able to define the sample space. Now, the next thing we want to talk about is an event space now. Now, pay attention. I'll give you some events. You will go on to tell me the event space. I didn't tell you to give me the number of elements in the event space now. Give me the event space. All right. Now, let's go on. The event of having weekend. The event of having weekend. Can you give me the event space for having weekend? The event of having weekend. Weekend. You will see that some of you may miss that question because some of you don't even know the days of the week that are associated with weekend. Okay, looks like somebody has gotten it. That's nice. Yeah, I told you somebody will get it wrong. Friday is not a weekend, by the way. Just so you know, we only have 2 days associated with weekends, and that's what? Saturday and Sunday. So obviously, some people put Friday there. Don't you go to class on Fridays? Friday is a weekday. All right. Weekends are associated with Saturday and Sunday. Now, if I ask you to talk about weekdays, can you give me the element of the event space for weekdays? Weekdays. So we're dealing with weekdays now. What are the elements there? What are the events? What's the event space associated with weekdays? So what do you call the event space for weekdays? Or that's weekdays, that's another event right there. All right. We can have Monday, Tuesday, Wednesday, Thursday, Friday, of course. Now, I also want to put this up there. Days of the week that has an S. Days of the week that has an S. What's the event space? Days of the week that has an S. Days of the week that has an S. Of course, you have that event being Saturday. That's another event that is possible there. Saturday and Sunday. Okay, if I say days of the week that has a hem, days of the week that has a hem, of course, another event there, I can have only Monday because only Monday starts with an hem. All right. If I say days of the week that has a T, in that case now you can have another event and you have Tuesday and Thursday. Now, this is a very great example for you to be able to understand how questions could be set for you in an exam hall. You can see that these are different events. So imagine now, let's now do a little bit of this. Imagine I ask you now, that what's the probability of you having to pick a day of the week that starts with an hem? What's the probability of you picking a day of the week that starts with an hem? Guys, can you give me the answer quickly? Let me see if you are there. What's the probability of picking a day of the week that starts with an hem? Of course, following the notation we just gave you, we said E4 represented the event of days of the week that started with an hem. What is NE4? The number of elements in E4. What's the number of elements in E4? We have 1. Okay, good. What is the number of elements in the sample space? That means what is NS? The number of elements in the sample space, we have 1, 2, 3, 4, 5, 6, 7. That's 7. Now, I told you guys already, it's the simplest thing once you are able to bring out the correct event space and the correct sample space. Your key to understanding probability is those two things: event space, sample space. When we get deeper, you understand that sometimes it can be much more technical to bring out event spaces and sometimes sample spaces. But let's start from a simple one. Now look at this. The probability of getting a day of the week that starts with an hem will obviously be 1 over 2 based on our probability formula. If I told you to give me probability of picking a day of the week that started with a T, of course, that will be 2 over 7. Guys, are you following me? Is it making sense? Because this is NE5. NE5 here will be equals to 2, and then the NS is actually 7. So that'll be 2 over 7. So guys, that's just how you deal with everything around probability. So let's go to another event, another random experiment, which is one of the things. Again, I will still come back to talk about throwing two coin and also throwing 2 dice. And I will also talk about drawing a card. Those are 3 things I want to spend time on, but I want to quickly run through all these very, very simple events so that you guys can familiarize yourself with this. Now, let's see one of the other events that we have here. If I say choosing a number from 1 to 10, guys, what's the sample space? Choosing a number from 1 to 10. Choosing a number from 1 to 10. What's the sample space? Choosing a number from 1 to 10. Good. I like that. Shoot me the answers quickly. I love to get the answers quickly because of time. So for your sample space, when you have a number, you're talking about numbers between 1 to 10. Of course, the sample space there, numbers between 1 to 10. Somebody wrote 0 to 9 now. That's going to be wrong. I said number between 1 to 10. Of course, the sample space there will be very simple and straightforward. This will be all of the sample space. Now, this is the interesting part. Can you guys give me the experiment of getting a prime number? The experiment, the event of getting a prime number. Give me the event space of getting a prime number. The event space of getting a prime number. I'm waiting. The event space of getting a prime number. The event space of getting a prime number. Okay, yeah, I knew you guys were going to miss it. Only some few people have gotten it. Let me say it loud and clear. 1 is not a prime number, all right? Prime numbers are numbers that has two divisors, one and itself. One only has one divisor. So one is not always regarded as a prime number. The prime numbers we have here is 2, 3, 5, and 7. Now, imagine for instance, you're told to get the probability of getting a prime number from from numbers between 1 to 10. Guys, give me that answer quickly. Probability of getting a prime number when you have this experiment. Of course, the experiment was you picking a number between 1 to 10. Choosing a number between 1 to 10 was the experiment. So if you have 1 to 10, to pick from 1 to 10, I said, what's the probability of you getting a prime number? A prime number. Of course, you have to just say, what is NE? NE here is 4. What is NS? NES here is 10. So obviously using this formula, that will be 4 over 10. That will be 2 over 5. That is how simple probability is, guys. It's as simple as this. Your key is finding the event space and your key is finding the sample space. So while you're studying, the only thing you have to do is to spend your time being able to detect the sample space and the event space. Once you are good at doing that, guys, you can never miss any question whatsoever in probability. All right. Now give me the event space of having even numbers based on this experiment. All right. Even numbers. What's the event space? Even numbers, guys. Even numbers. Oh yeah, shoot me the answers quickly, guys. Even numbers. Okay. Even numbers we have 2, 4, 6, 8, 10. Now, I want to repeat this for those that have been following. If you go on to write a 12 here, you write 12 here. 2, 4, 6, 8, 12, 10, 12 is not a subset of sample space S. I told you guys already, your sample space is always the broader set. Your event must always be an element of the sample space. In any case where it's not the element of a sample space, that tells you that that is an impossible event. All right. So always note that. That's one of the issues that students used to have when you are not able to identify the event space and you are bringing in something that is not a part of the sample space. Now, guys, perfect squares. Give me the event space of perfect squares. The event space of perfect squares. Based on this experiment, give me the event space of perfect squares. Give me the event space of perfect squares. Perfect squares. Perfect squares. Perfect squares. Perfect squares. You see, this is, you can see how we are, as we are graduating, can you see how you guys are no longer getting all the answers perfectly? Because once you have issues in bringing out the event space, there will always be an issue in solving. So your key to understanding probability is knowing how to always bring out the perfect squares. Sorry, bring out the event space. I've only seen a few answers here. Perfect squares are obviously those numbers that when you have their square root of, they are going to give you a perfect number. Among all these numbers you have from 1 to 10, this is one of them, this is one of them, this is one of them. Any other number is not one of them. So you have the elements of the event space for perfect squares being 1, 4, and 9. So that means, can you understand this now? For those of you that did not get this, I want you to get enlightened. Can you imagine I told you, I asked you, I said, what's the probability of you getting a perfect squares from this random experiment of picking a number between 1 and 10? What's the probability of you picking a perfect square when you have a number 1 to 10? Now, if you are not very sure of your event of perfect squares, what your event space should be, of course, you understand that you would have omitted 1. Some of you just wrote 4. Some of you omitted 9. Some of you just wrote 4 and 9. In that case, some of you would have written 2 out of 10. If you wrote 2 out of 10, that would have been a wrong answer. All right. If you wrote 1 out of 10, that would have been a wrong answer. But if you wrote 3 out of 10, you would have gotten the correct answer. So this is the way you answer questions. You have to always be able to bring out the event spaces. All right. Now, let's go to a different event. Now, selecting a month. Guys, selecting a month. Selecting a month. What's your sample space there? Selecting a month. Oh yeah, toss me the answers quickly. Let's toss the answer in like seconds. Selecting a month. Good. Okay. Now, I understand it's quite long. You don't have to write everything. All right. Now, guys, this is the event space I want you to bring out. Event of a month that ends with 31 days. Event of a month with 31 days. Oh yeah, give me that event space. That's the event of having a month with 31 days. Event of having a month with 31 days. Month with 31 days. Month with 31 days. Are you seeing how this thing goes? You have to be very versatile. Yes, exactly. That person asking about sample space. In this case, under that experiment, sample space is the universal set based on that experiment. All right. So now, you're talking about months that ends with 31 days. Of course, you have January there, you have March there, you have May there, you have July there, you have August there, you have October there, you have December there. How many numbers of elements? What's the number of elements in the event space, guys? What's the number of elements in the event space of a month that ends with 31 days? What's the number based on what you wrote? What's the number? Of course, that'll be, is this 8? Okay, some of you wrote 8. It's actually 7. It's actually 7. So you see that that's very key, because once you miss one out or you increase it, I'm sure you know that that will give you the wrong probability. So imagine I just told you to give me the probability of the number of the probability of picking a month that ends with 31 days. Of course, that will be 7 out of 10. Good. By the way, if you are here, you've not given this video a thumbs up, please do that very quickly. And that's a good way of appreciating us. Give us a thumbs up very quickly. Now, I want to go to one last one before we then run into those 3 important things that we talked about. I want to go into one last one. Selecting a student's grade. Guys, based on what you guys know, what's the system you run, guys, selecting a student grade. Imagine I want to select a student grade. Can you give me the sample space? Can you give me the sample space of selecting a student's grade? So imagine you are conducting an experiment of what are the possible grades that a student can have. All right. And of course, based on what you guys have, what's the sample space for that event, for that experiment? Selecting a student's grade. Okay, good. Good. That's great. So if I ask you to give me the event of passing grade, what is regarded as you passing? You passing. All right. You passing. The grade that is regarded as you passing. Of course, the sample space for the whole thing is A, B, C, D, E, F. Good. Now the event of a student passing. Oh, somebody said A and B. Okay, maybe we should use that. But no, obviously, it's actually A, B, and C. So of course, failing will be regarded as D, E, F. All right, so I can see, guys, can you please identify now that you truly understand everything we have just done on the basis of sample space and event space? Can you give me your feedback quickly? Is anybody there still having issues? I still have, of course, other experiments, but I don't want to exhaust them because I want to spend time on the other things I mentioned. If you know you are here, can you give me your feedback, guys? I want feedbacks. You understand? You really understand? You really understand? Give me your feedback. You're flowing well with us. You really understand what we're doing, right? Anybody with any Anybody with any question, please ask it quickly. This is an interactive class. We want to hear from you. So guys, I want to if we don't have, okay, I love it. Okay, who have a question? I think I have somebody asking a question there. Please, can you shoot your question quickly so we can answer you quickly? The question, please. Okay, everybody seems indefinite. Somebody asked if the sample space is indefinite. You can't have a sample space that is indefinite in probability. All right. Your sample space must be clearly defined. Or if it's not clearly defined, then you cannot talk about a probability of anything happening under that experiment. Any experiment without a clearly defined sample space, it's not an experiment that you want to deal with, because every experiment must have like the total number of possible outcomes. That's why you call it an experiment. It's like saying you want to toss a die, like you're playing a game, you're playing a Ludo game, but you don't know all the possible numbers that can come out. All right. So you can have a 50, you don't even know. That's not going to be an experiment. That's not going to be something many people are going, you're not going to have something like that. So you must have a definite sample space, a definite possible outcomes of the experiment. If not, your experiment is invalid, because it's not an experiment. What are you experimenting when you don't have even all the possible outcomes? You don't know what's possible. It's not an experiment, so you can never get an answer there. All right. All right. Okay. Are you saying that to shoot on Arsenal fans? Okay. So, guys, let's move quickly to the next subject. I didn't want to match the discussion around tossing two coin and tossing two die up, because I'm very sure this is something that I have to explain to some people. I'm sure some of you probably understand what to do here. Now, guys, let's talk about this experiment. You have two coin. We won't talk about tossing two coin up. You have two coin in your hand. You toss it up. Guys, what's going to be the sample space? Can anybody give me an intelligent answer there? What's going to be the sample space when I toss two coin up? The sample space now obviously cannot be head and tail, because the possible outcomes there is not just head and tail. Because if I throw two coin up, my possible outcome is no more just head and tail. Somebody said head two times, somebody said tail two times. Okay. Okay. I have not, do you know I've not gotten any answer here? Exactly. This is the reason why I needed to explain. Right? Reading through the charts now, nobody has given me any correct answer. Somebody said head, tail. Somebody said head, tail. Somebody said tail. Somebody retracted the answer. Somebody said head, tail. Somebody said head, tail, head. Somebody said two head, two tail. Another person said two head, two tail. Great. This is the reason why you are right here in class, because nobody has actually gotten the answer. Now, thank you. Yeah, it looks like somebody. No, he didn't get the answer. I thought somebody just got it, but the person did not get it. No, you think I'm seeing everybody's answer, by the way. Yeah, somebody just got it. Samuel, give it up for Samuel. Give it up for Samuel. Samuel is the only person that has gotten it correctly. Every other one were close, some were far. But this is it, guys. How do you get the answer? Let's look up, let's pay attention. How do you get the answer around having two coin? So look at it. Let's take these two coin as the experiment. So you lift these two coin up, you toss it up. Don't forget what the definition of sample space is. Total number of possible outcomes. Once you retract one answer, of course, you know that that is no longer the sample space, because the sample space must embed into it all the possible outcomes. All right. Now look at it. In this coin, we have head in front, we have head at the back. We have head here, we have tail at the back. I'm sure you know that if I toss this coin up, both of them up, there's a chance that coin one will give me head, coin two will give me head. That means both of them give me head. That's a possibility, right? Now, I did not say the next torso. I'm saying possible, because you need to understand that it's possible you throw these two coin up and the first one give you head. I throw it up again, it's still head. I did not say the next toss, but let's try to think about other possible outcomes. It's possible that you toss this coin up and the first coin gave you head, and also the second coin gave you tail. It's possible this happens also. All right. This is also a possibility. Abi, is there anybody in the chat section telling me that this is not possible? It's possible. It's possible the first coin gave me head. It's possible the second coin gave me tail. Now, look at it. It's also possible that the first coin was one that gave me tail now, and the second coin gave me head. This is also possible. All right? Anybody disputing that this is also a possibility? Don't forget, sample space said it's the total number of possible outcome. Once you remove one, you have not completed the sample space. So another possible outcome. Can you guys tell me the last possible outcomes here? Outcome here? Anybody? The last possible outcome. The last possible outcome. Anybody there? What's the last possible outcome that you can see right here? Tail. Thank you very much. It's possible the first coin gave me tail, and the second coin gave me tail also. Now, is there anybody there that you have another possible outcome that I have not written? You're free, because in case I probably have omitted something, we must complete it. So do you have any possible outcome that is still omitted here? Someone said head tail. This is head tail here. It's there. First coin give me head. Second, okay. Someone said tail head. This is also there. So that's possible. Tail, that's also there. Any other outcome that is not here? Of course not. So this is my sample space for tossing two coins. This is the sample space. Guys, can you see that? This is how interesting it is. Okay. We have this as the sample space. I did not say event space now. Sample space of tossing two coins up. Guys, are you feeling that? Now, let's talk about different events that will happen now. Are you ready? Let's talk about different events. Different events. For instance, now, guys, I say, imagine I tell you to tell me the event space when you have the first coin giving me head and the second coin giving me tail. Can you give me the event space of that, guys? Please follow me. The first coin has head, the second coin has tail. What's the event space? Now, this is the reason why somebody wrote HTTH. HTTH is not correct. Somebody wrote THHT. That's not correct. Somebody wrote HHHT. That's not correct. Somebody said, you see, you guys need to understand event space. Event space said first coin. Imagine I said, what is the probability that the first coin gave an head and the second coin gave a tail? Many of you are missing this, and that's the reason why, again, that's why you are in this class. HTTH is wrong. I said first coin gave an head, second coin gave a tail. First coin gave an head, second coin gave a tail. This is the only event that accommodates that. First coin gave an head. This is the only event. This is the only event. All right? You cannot have HH or TT. No, that's not going to be correct. This is the only event that is inclusive of first coin being a head, and second coin being a tail. All right? Now, let's talk about some other events, guys. Imagine I say, what is the event space that you have? Okay, don't let me go there yet. Both coin giving you a head. Both coin giving you a head. Oh yeah, give me that one. Let me start from the easy ones. Guys, this is very vital. You get this right, you can never miss any question on probability. Both head gave me head. Good. I see everybody are clearing that. I've not seen any wrong answer. So the event space of both head giving me a head, both coin giving me a head is HH. Good. And I'm sure, somebody still wrote a wrong answer. What's that? Please let me believe that that's not an answer for this question. This is the event space for both coin giving me head. This is the event space. Very simple. That's the event space. For both coin giving me head, that means this is head, this is head. First coin is head, second coin is head. All right? Good. Now, please listen well to the question, all right? What's the probability that either one of the coin had head and the second coin had tail? Either one of them had head and the second one had tail. Either one, that means one of it may be the first coin that has head, the second one has tail, or the first or this. What's the event space? Who is writing 1/2 there? I didn't tell you to give me the number. I didn't tell you to give me the number. I'm telling you to give me the event space. Give me the event space that either one of them, that means one of them is either head, the other one will be tail. I'm not asking you to give me numbers. You guys give me numbers. Okay, maybe I misspoke. I don't want the probability yet, guys. I want the event space. Give me the event space that I have one of them giving me head. Of course, if one give me head, yeah, I'm seeing the answers right there. So this is obviously it. The event space for that will be head, tail, tail, head. This is it. Now, let me get right into some interesting ones. Guys, are you ready? This next question, I want to see who gets the event space. Are you guys ready? Okay, good. What is the event space of at least one head? At least one head. The event space of at least one head. At least one head. What's the event space for that? At least one head. Oh yeah, get giddy. Oh yeah, send the answers quickly. At least one head. At least one head, okay? At least one head. I'm seeing the answers. I'm seeing some wrong ones. At least one head. At least one head. Of course, that event space is concerned about making sure that when you are dealing with this coin now, at least I must see head there. Okay, I'm seeing many of you flowing. That means I can have HH, both of them head. That's at least. I said at least. That means the least possibility is one head. I could have two heads. Okay. Head, tail, tail, L. You can see that TT is not included because they said at least one head. So this is contrary to that statement. Give me the event space for Hey, I don't want to ask this one yet. Okay. One head. Give me the event space for one head. Event space for one head. I want to get into some tricky questions on this event space. On one head, just give me the event space for one head. One head, guys. Why am I saying HH? One head. One head. When you write HH, that's already two head. Wow, this is quite interesting. One head. Where do I see one head? Okay. Okay, good. This is it right here. One we did before, one head, because this is one head happening here. Okay, guys, let me see who is going to get this. I'm very interested in seeing who gets this. Not more than one head. Event space for not more than one head. Not more than one head. Let me see who gets this. Not more than one head. Not more than one head. Guys, it's getting hot, right? It's getting hot. This is where you get this is the core of probability. Once you understand the event space, the sample space, you are done with probability. Yeah, I can see many people missing the answer. I said not more than one head. Good. That's why we're here. Obviously, we are here because we are going to give the best understanding on this concept on probability. Yeah, many of you got some of you got the answer, not many of you did. Not more than one head is what I said. Not more than one head. Guys, under probability, not more than one head. Of course, not more than one. I don't want to see head because HH is more than one head. HH is more than one head. So my concern here is HT, not more than one head. HT is included. TH, it also, of course, don't forget your element of your event space must always be, your event space is always a subset of the sample space. So you know about that. Now, not more than one head. Guys, am I going to include TT or not? Not more than, it should not be more than one head. TT is involved because in this case, not more than one head means I can have 0 head or I can have 1 head. This is not more than, this is still under not more than 1 head. 0 head is part of not more than 1. 0 head is 0 head more than 1 head. 0 head, is it more than 1 head? No. So not more than 1 head. Yeah, someone is admitting is getting very technical. That's why we are here. Don't worry, just focus. I'm trying to demystify all the things around probability. Not more than 1 head. 1 head is included. 0 head is also included because 0 head is not more than 1 head. It's not more than 1 head. All right? It's not more than 1 head. So the question did not say you must have head. It said it shall not be more than 1 head. So when I see no head, I said at least this is still part of it because it's not more than 1. All right. It's different from when I said at least 1 head. Because in that case, I'm saying I must see 1 head. I must see 1 head. All right. But when I say not more than 1, when I see, I'll give you the cheat. Somebody is talking about 3 coins. You will see how the cheat code of solving all these things very easily. How to bring out the sample space. I'll give it. I first want you to understand all these things before I give you some simple ways of getting this. Now, not more than 1 head, obviously, is 0 and 1 head. At least 1 head means I can have 1 head, I can have 2 head, but I must not have 0 head. That's the way it goes. Guys, we're moving forward. All right. Are you seeing why it gets interesting? Yeah, probability is very interesting. All right. Victor, waiting, Mr. Ajala, do you? So, guys, okay. So, do you want more on this? So let's do the converse of all this. If I say at least 1 tail, what's going to be? Give me the, okay, let's do this. Give me the event space for at least 1 head. Sorry, at least 1 tail. Sorry, at least 1 tail. Can you give me the at least 1 tail? At least 1 tail. So guys, you use this one to stand though. At least 1 tail. Don't give me the wrong answer. At least 1 tail. Yeah. Yeah, that's what I want to see. I'm saying, oh, who is that person that, oh, somebody wrote HH there. I said at least 1 tail. At least 1 tail. HH cannot be included. There's no tail there in HH. So HH cannot be included. At least 1 tail must have at least 1 tail. Anything where tail no dey, you no go fit put am. Shey you get? So the event for at least 1 tail will be HT, TH, and TT. All right, guys? Because at least 1 tail, HT, that's, I can see 1 tail there. I can see 1 tail here. I can see 2 tail here. I'm still on point if I see 2 tail. But if I now say, guys, answer this one. If I say at most, at most, at most 2 tail. At most 2 tail, what's the answer? At most 2 tail. Guys, it's getting hot, right? At most 2 tail. Guys, at most, two tail, at most. Understand the language. At most, at most, at most. The highest must be two tail. At most. Guys, pay attention to the this thing. At most two tail. At most two tail. At most two tail. At most two tail. That means when you hear at most, that means the highest you must have must be two tail. But anything lower than that is also accepted. The at most. That's the meaning of at most. When you see at least, that means the least thing you must have must be that number they mentioned. So when I say at most two tail, that means I'm interested in the highest you must have must be two tail. Now, if there was a possibility of having three tail, you must not include that. So I'm okay with two tail being included. I'm okay with one tail being included. I'm okay also with zero tail being included because zero tail is still in between this. At most, the highest you must see must be two tail. This is how you are able to solve out your answers. If you don't know how to interpret these grammars, that's where issues come. At most, two tail. So two tail comes up here. Two tail comes up at most of two tail. This is one tail here. I'm still fine with it. This is also one tail. I'm still fine with it. Now, at most two tail. This is zero tail, but it's still in between the bracket of at most two tail. Yeah, you guys are very correct. Not what you guys are saying that English is very important here. Very, very important. That's why the introductory class we're trying to bring out all this, solve out all these things so that you guys have a perfect understanding. So make sure when dealing with probability, please make sure you have proper understanding of the use of the word at least and at most. At least means the least thing you must see must be, if I say at least one tail, that means the least I must see in that experiment, I must see one tail in that event, right? So I see one tail here, I see one tail here, I see two tail here. Because I said the least must be one tail, this is two tail is still okay because it's still in between, it's still in the concept, in the whole thing. All right. Now, if I say at most two tail, that means the highest I must see must be two tail. Now, guys, answer. At most one tail, what's going to be? At most one tail, what's going to be? At most one tail. At most one tail. At most one tail. At most one tail. Somebody is still writing only two. At most one tail. Good. So at most, that means the highest I must see must be one tail. In that case, you cannot include your two tails. I cannot have, if I say at most one tail, two tails must not be included. Every other one falls well because this is at most, this is one tail, this is one tail, this is zero tail. Zero tail is still between, is still under, is still in between in the context. All right. So guys, that is this is very great for shaking you up. So you guys, I believe at this point now, you guys are not wrong. English is part of all these things. You're not wrong. Now, I told you already, I want to give you an easy way of bringing out the sample space when dealing with things like this. So now, before I give you, let me get you first into hot water, then I'll bring you out of it. Let's try to do for that of to die, because you will know the importance of what I want to do next when you attempt to do that of to die. Or probably if I asked you, somebody mentioned, maybe we don't go into to die first. Somebody mentioned about 3 coin. Guys, imagine we have 3 coin. Oh yeah, can anybody give me the sample space? 3 coin. Oh yeah, you're having 3 coin now, no longer 2 coin. You have 3 coin. Yeah, give me the sample space quickly. Tell me what the sample space for 3 coin will be, guys. 3 coin. 3 coin. Oh yeah, I'm waiting. So you have 3 coin. Of course, I'm sure you know when you throw the 3 of them up, what are the possibilities? Okay, so you can see 1, 2, 3, 4, 5, 6, 7. I just need all I need to do is to just count 1, 2, 3, 4, 5, 6. And you don't get, we have not gotten so much of the answer. I'm trying to see 1, 2, 3, 4, 5, 6, 7, 8. It looks like somebody is close there. I think somebody's writing too tall. What's Larry writing? Too tall. Too tall is part of the okay. 1, 2, 3, 4, 5, 6. Yeah, so we don't have so many answers. Yeah, that's the reason why I told you I want to put you into hot water first, and I'll bring you out. So that's what we're trying to do here. So, guys, many of you did not get the answer. Probably only one person had probably the answer. I didn't get to check the whole element, but I counted it and I saw the person was the person was a bit based on the numbers, and the numbers that the person gave me was 8. So if you don't have 8 answers as your element, you are just not it, because you must have 8. So guys, yeah, let's before we even go into die yet, let's even talk about coin. When you want to bring out the sample space around all these things, there's an easy way of doing it without getting it wrong. All right, look at it. Just write the first coin. Write H, the possibility of the first coin. That's H, and that's T. That's for this. Write the possibility of the second coin. I'm talking about 2 coin for this one. Talking about 2 coin, by the way. I'll go into 3 coin. Then you guys can do for 4 coin, 5 coin. You guys become experts. You'll be able to do for 10 coin itself. Are you not excited about that? You'll be able to do for any number of coin easily without missing anything. So it's very easy. It's very simple. And that's why we're here. So the first thing you have to do, we're doing for 2 coin now. I won't bring out this without having to guess any of all these things. First of all, write the possibility of the first coin, HT. Write the possibility of the second coin, HT. All right. So you know what you want to do? You want to put this out there. All right. Are you seeing what I'm doing here? So probably I don't do this. I don't know. Maybe I should be a bit careful of doing this so that, or maybe I do it. You can understand. This is the this, you obviously know this is the possible outcome for the first coin. This is the possible outcome for the second coin. So what you want to just do is just simple. Yeah, you just want to say HH, write it there. HT, write it there. TH, write it there. TT, write it there. Bring all the elements inside all this place. HH, HT, TH, TT. That's your sample space. Simple, right? Very easy. Always easy. Maybe we should rename this channel Easy Mathematics or something like that. Always easy. Math is very easy. I always tell you guys. Now, I want to do for 3 coin. You see how I'm going to do for 3 coin without sweating at all. Now, I want to do for 3 coin. You know what you're going to do? You have to have done for 2 coin before you can do for 3 coin. So if you are going to do for 3 coin, you bring out your response of 2 coin. Can you see this is the response for 2 coin? So you're going to put that one as the horizontal now, the response for 2 coin. HH, HT, TH, TT. All right. So you want to do that like this. Then you want to bring out, this is 2 coin. This is for 2 coin. You want to bring out for just 1 coin now. 1 coin. So you want to write HT, 1 coin. So of course, the total here will be 2 plus 1, that's 3. So this is 3 coin. So what you want to do to bring out the possible outcomes, that's the sample space, is go on and have H, you hold this with everything here. That will be HHH, HHT, HTH, HTT. Next one, THH, THT, TTH. Next one, TTT. You can never go wrong doing it this way. So this will give you the total number of possible outcomes for tossing 3 coins. So you can go on now to cross-check this with all the answers you gave me. These are the answers, obviously, for 3 coin. 1, 2, 3, 4, 5, 6, 7, 8. So if you toss 3 coin up, this is the sample space. Now, this means that if you toss 3 coin up, you can have H, H, H. Of course, that's possible. First coin gave you H, second gave you H, third gave you H. It's possible you get HHT. It's possible you get the first one giving you head, second one giving you tail, third one giving you head. All these are the possibilities. And this gives me a total of what? 8. Now, guys, I want to ask you, how do you feel about this method? Simple or easy? Which one? Or super easy? Do you get it? Did you understand what I did to get these answers? So you can see already that if I ask you to bring out the total number of possible outcomes for an experiment that involved tossing 3 coin, this is the total number of possible outcomes. Now, can you guys now imagine? Are you seeing how beautiful probability can be? Can you imagine me asking you that what's the probability of getting at least 1 head? At least 1 head. Guys, shoot me the answer quickly. Probability of getting at least 1 head. What's going to be? Probability of getting at least 1 head. Probability of getting at least 1 tail. Probability of getting at most 2 head. Probability of getting a head, then a tail, then a head. Now, I want you to be very aware of the possibilities of questions that can be asked you when you are dealing with probability. Now, all these things are the things you are going to be dealing with when we start solving questions. This is just for you to understand the whole concept of bringing out, extracting your sample space and also your event space. All right. So guys, I want you to give me now very quickly the sample space for tossing 4 coin up. The sample space for tossing 4 coin up. 4 coin. Do it quickly in your note and throw me the answer. I don't expect nobody to miss it because this is some. Can you just for me to be sure that you know what you're doing? Can you give me the sample space for tossing an experiment that involves tossing 4 coin up? Give me the sample space in 1 minute. Let me be sure you know what you're doing. Then I'm going to tell you something very soon now of how you can get these answers without even drawing any of these things, like getting the number of elements of the sample space without having to draw any of these diagrams. I'm going to get into that in a bit. But first, give me your answer for the sample space for tossing 4 coin up. This is for 2 coin. We've done with just 1 coin. That is quite very easy, head and tail. This is for 2 coin. This is for 3 coin. Can you guys give me that for 4 coin? When you toss 4 coin up, can you give me the answer? What's it going to be? Tossing 4 coin up. No, I didn't tell you to give me the number of elements. I'm telling you to give me the sample space. I want to actually see the sample spaces. The sample space, rather. Do we have any answer there? It looks like you guys are frozen. You're frozen in time. What's going on? Okay, yeah, we have an answer. Good. I'm going to count to know if you're correct or not. Yeah, we have an answer here. Good, that's nice. Yeah, that's the point. You're going to have long answers, guys. Okay, so it looks like you guys know what you're doing. Good. Are we getting an answer less than 16? If your number of elements is less than 16, that means you are not correct. You must have the total number of elements in your sample space as being 16. So guys, let me give you a way of cross-checking the number of elements in your sample space without even having to do anything. So pay attention. The general rule to know the number of elements in your sample space is this. Look up, please. If you are right here, you can pay attention. The number of elements for your sample space will always, when tossing a coin, the number of elements will be what? 2 raised to the power of n. 2 raised to the power of n. Please write that down somewhere. For a coin, I'm indicative of this being for a coin. For a coin, it is 2 raised to the power of n. This n representing the number of coin. So for instance, when we are dealing with 2 coin, like in this case, the number of elements for the sample space was equals to 2 raised to the power of, how many coin do we have? 2 coin. That's why we have the total number of elements here to be 4. All right. Is priest on this chart? I've not seen priest at all. Now, for 3 coin, notice what happened. We had 2 raised to the power of 3. That's 2 times 2 times 2. That is 8. You can see that the number of elements for our sample space was 8. All right. So when I asked you to do that of 4 coin, tossing 4 coin, for you to know the number of elements that is going to be in your sample space, all you had to do was to say 2 raised to the power of n here being 4. That'll be 2 raised to the power of 4. That will be 16. Now, I want you to understand that there are some questions you'll be asked that would not involve you bringing out all these things. You'll get there very soon when you're talking about complementary events, where you do not need to deal with bringing out all the events, and you will still get your answers. We'll get there very soon. That's some of the very, very interesting part of. Yeah, if you're told to highlight all the sample space, then you obviously have to highlight all the sample space. All right. So you need to be very much aware of that. That some questions may say, bring out all the questions, all the sample space. In that case, you have to. All right. Now, look at all this pattern and make sure you note it so that you don't have to always be distracted. In a case where let me ask you guys randomly. If I'm having 5 coin, what's going to be the number of elements of my sample space? 5 coin. I'm having 5 coin. What's the number of elements of my sample space? If I have 5 coin. Anybody? Yeah, exactly. What about 6 coin? What about 6 coin? Good. That's perfect. So that means I've been able to communicate everything around this sample space, around a coin. Let's dive into dice now, because that dice is far much more than a coin. A coin is coin is plain when dealing with die. When dealing with a die, dealing with a die is much more. It comes with much more than a coin, because a coin just has two different head and tail, and then you keep moving. All right. But it's when you're talking about a die. But of course, now that you understand the concept of coin, I'm sure you can also replicate that into a die. Now, guys, let me start from the end to go to the beginning. I'll start from the end of where we stopped when dealing with the coin. We'll use that to start from the dice. So you don't have to sweat too hard. When you are told to find any random experiment that involves a die, the formula to get the number of elements of the sample space for a die, this is for a die now, not for a coin, will be 6 raised to the power of n. Are you seeing the pattern? 6 raised to the power of n. That for die, that for coin was 2, because we had head and tail. That was the representation of the 2. For a die now, we are having 6 possible outcomes for the first coin. So you have to have it as 6 raised to the power of n. So guys, without wasting time, you are going to give me now, if I have n here being the number of die, so let's say, for instance now, if we're dealing with 2 dice, okay, let me start from 1 die. What's the number of elements of the sample space if we're dealing with 2 dice? Sorry, 1 die. If you're having 1 die, what's the number of elements of the sample space? 6. Okay, for 1, that will be 6 raised to the power of 1. That will be 6. So you already understand that when you have 1 die, your number of elements in the sample space is 6. If you have anything other than that, you know you are wrong. What about this is for 1 die. For 2 dice, what's it going to be? That'll be 6 raised to the power. So that'll be what? 36. So your sample space will be 36. All right. Good. So let's do one that is not very common. For 3 dice, that'll be 6 raised to the power of 3. And that's what? Did somebody write 26 there? 216. Good. So I'm sure you have a little bit of rest now. You don't feel, you're not very afraid of die, because now that you know how to deal with all these things. Now, the same way now, I do not imagine you trying to bring out your possible outcomes now. That means your element of your sample space from your head. What you have to do, if you're trying to bring out that of 2 dice now, for instance, all you have to do, guys, is to go on to just say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. This is how you bring out the total number of elements when dealing with 2 die, total number of elements of the sample space. This is how you bring the possible outcomes out, the sample space. So just take, for instance, just for you to understand the experiment, you have 2 die in your hand. You toss it up. Of course, there are different possibilities. It's possible you have a 4 as a first die, and you have a 6 as a second die. It's possible you have a 2 as a first die, and a 2 as a second die. It's possible you have a 2 as a first die, and a 5 as a second die. It's possible you have a 5 as a first die, and a 3. All these are possibilities when dealing with a die, 2 dice rather. So look at all the representation of all the possibilities. And you guys will have the opportunity of questioning if we are correct or not. It's possible this is die 1, this is die 2. It's possible you have 1, 1, first die being 1, second die being. Look at all the possibility. You just pick this together. 1, 2, 1,3. I'm sure you are taking good notes. 1,5, 1,6. If you are taking good notes, all this should be represented in your notes. Because you will see the very soon now, not in this class, obviously, you will be using all these possible outcomes to solve several questions. So the importance of being able to bring it out, as I've told you already, is that if you're able to bring out the sample space and the event space correctly, you can never, I assure you, miss any question on probability, because that is like the oil, of course, I mean the main thing you need for you to solve any question on probability. Once you are very good at doing that, you are, of course, good to answer any question. So this represents all the possible outcomes that I'm sure of for 2 die. Now, if you are there and you feel that I've not represented something on this in front of us, that probably something is not included, that you know that it's possible for you to toss two dice and you're not going to get, and you have not, I've not included the answer, please signify very quickly. Possible I've omitted something. You know you are there, you have any objection to probably there's a number not included, you can signify very quickly. Now, for somebody asking for if it was for 3 dice, I told you guys already, that's going to be, of course, a lot of big deal. I'm sure you understand why. Because 3 dice, all you need to do if you are mandated to bring out the possible outcomes of 3 dice is that you will go on to write all these things. Every one of them. That's 36. This is 36, obviously. If you count it, 1, 2, 3, 4, 5, 6, you count everything, that will be 36. You write all these 36. You write them horizontally. Then you write a vertical 1 to 6 again, and you go on bringing out. So the first, of course, you may not even need to even do that, by the way. I can bring it out even with this particular table, because the first one will be 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, 1, 1, 5, 1, 1, 6. That's the possible outcomes for 3 dice. 2, 2, 1, 2, 2, 2, 2, 2, 3, and so on. 3, 3, 1. That's where I'm going to bring out all the other 2, 1, 6. Of course, I will have to use 1 to also touch every other one. So 1 is not going to touch just this first one. 1 is going to touch this. 1 is going to touch this. 1 is going to touch this. So I'm going to have 1, 6, 1, 1, 6, 2, 1, 5, 1. I'm going to have 4. That's the way you're going to do it. You do 1 for everything here. You do 2 for everything here. You do 3. You have 3, 3, 3, 1, 1. 3, 2, 1. You have 3, 2, 2. You have 2, 4. That's the way you're going to bring out everything. You must have a total of 2, 1, 6. I do not see any exam that you're going to ask you to bring out something like that. This is going to be the highest you would mostly go in the level you are in. Now, guys, let me now tell you why this issue of dice is one of the most, the part you have to pay attention to is that the number of questions that can come out from this is quite many. So guys, you're going to give me in the comment section now this event space I'm going to be mentioning. All right, are you ready? I want to get this event space. Shoot me back the event space that I'm going to be mentioning. Now, guys, tell me the event space that the total score that show up. The total score that show up is 8. Tell me the event space for that. The total score that show up is 8. The total score that show up is 8. Oh yeah, give me the event space. Now I'm sure you don't have an issue with bringing out the sample space, because I brought out the sample space. All what you have here is the sample space. So give me an event space that the total score that show up is 8. Guys, I want to get answers from you. The total score that show up is 8. I didn't say you should give me the probability. No, no, no. I didn't say you should give me the probability. I said give me the event space. The event space that the total score that show up is 8. Okay, somebody wrote something there. Now, somebody wrote, now look at this answer that I see right here from Praise. Praise wrote 35536226 7117. Guys, it's 7117. Now, if I told you already that your event space is always a subset of your sample space. Do you see 7117 as any element in your event space? Of course not. There is no die that you throw that gives you a 7. So you do not have a 7 associated with this experiment. So you see that those two elements, 71 and 17, they are not correct. So let me see other answers, other responses. Okay, 1, 2, 3, 4, 5. Okay. Now, 1, 2, 3, 4, 5. Okay, good. I'm getting the right answers and I like to see that. So let me try and identify that. Look at the total score that show up is equal to 8. Event space associated with that. All this, total score 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. And 2 plus 6 is 8. This is the only one that is equivalent to 8 as total score. When you look at all these ones, they are less than 8. This is 3 plus 3, 6. 3 plus 4, 7. 3 plus 5, 8. This also is part of it. 4 plus 7, this doesn't work. 4 plus 4 works. This is an event space also that gives me the total score to be 8. This also works. This also works. Is there any other one that works that I have not added? Is there any other one that works that has not been added? Now, this is the event space. For those of you that wrote 1, 2, 3, 4, 5, this 5 as your event space, you are perfectly correct. All right? That's the way you solve questions around probability. You must know how to bring out the sample space, the event space. So if I now asked you guys, now what is the probability of getting a total score of 8 when you toss 2 dice? Are you seeing how very interesting and solvable that will be? What's going to be your answer, guys? Someone said 4. Is it 4 out of 36? The number of elements of this event space, 1, 2, 3, 4, 5. That's actually 5. That will be 5 out of 36. Now, another question that is also possible to be asked, which is quite, this one, I will see how you're going to fare with this one. Guys, this is going to take you logical reasoning. What's the probability? Okay, don't give me the probability. Just give me the event space. And that the total score that show up is equal to a prime number. Give me the event space now, that the total score that show up is the total score that show up. That means when you added the two, the total score that show up is equal to a prime number. Are you understanding now how you can bring out several events from just this experiment? So we can have several events that comes from the tossing of 2 dice. So it's possible the first one I asked you now, the event of you getting a total score that was equal to 8. Now this question is asking you to give me the event space of a total score that show up being a prime number. So okay, I thought I saw an answer from someone. Okay, can I get the event space that is associated with total score showing up being a prime number? Of course, in this case now, if you do not know what a prime number is, you will not be able to bring out the event. You need to know what a prime number is. A prime number is a number that has 2 divisors. That's one and itself. So first of all, what are the numbers that are right here? That when you add them together, you're going to get a prime number. Look at it. 1, 1 gives you 2. This is one of them, one of the events. Of course, this class is meant to open your mind to possibilities in exams when it comes to this is a very valid question, and I want you to understand that when you're in an exam, or if you miss just one event, if you do not had an event, that's imagine the last question we just solved. Now imagine your probability was 4 out of 36 instead of 5 out of 36. That would have been a total mess. So it's like you understood the thing, but you made the mistake of omitting one event, and that's the reason why you have to be very careful. So 1 on 1 is correct. 1 on 2 is part of it because 1 plus 2 is 3. 1 plus 3 is not part of it because that's going to give me 4. 1 plus 4 is part of it, that's going to give me 5. 1 plus 5 is not part of it, that's going to give me 6. 1 plus 6 is part of it, that's going to give me 7. 2 plus 1 is part of it, it's going to give me 3. 2 plus 2 is not part, it's going to give me 4. 2 plus 3 is going to give me 5. 2 plus 4 is not part, it's going to give me 6. 2 plus 5 part because it's going to give me 7. 2 plus 6 not part, it's going to give me 8. 3 plus 1 not part is going to give me 4. 3 plus 2 part is going to give me 5. 3 plus 3 not part is going to give me 6. 3 plus 4 part because it's going to give me 7. 3 plus 5 not part is going to give me 8. 3 plus 6 not part is going to give me 9. 9 is not a prime number, guys. This is not odd number, by the way. 4 plus 1 is going to be part. It's going to give me 5. 4 plus 2 is not going to be part. It's going to give me 6. 4 plus 3 is going to give me 7 parts. 4 plus 4, 8 is not going to be part. 4 plus 5, not going to be part. That's going to give me 9. 4 plus 6, that's 10. Not going to be part. 5 plus 1, not going to be part. That's 6. 5 plus 7, going to be part. That gives me 7. 5 plus 2 rather gives me 7. 5 plus 3, not part, gives me 8. 5 plus 4, not part, gives me 9. 5 plus 5, not part, gives me 10. 5 plus 6, part gives me 11. That's a prime number. All right. 6 plus 1, 7, going to be included. 6 plus 2, 8, not going to be included. 6 plus 3, 9, not going to be included. 6 plus 4, not going to be included. 6 plus 5, going to be included. 6 plus 6, not going to be included. Guys, can you see how I'm able to bring out the event space around this? If you're right there, you got all this, can you please signify? You got all this. You were able to bring out all the event space. You're able to bring out all of the event space. So, guys, can you go on now to tell me the total number of elements in your own event space? All right, give me the total number of elements in your event space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did you get 15? Did you get 15 as your answer? Did you get 15? Okay. Now, those of you flowing with this class, this is a good way to introduce yourself to probability. Once you are perfect, I repeat, in bringing out the event space, bringing out the sample space, you can never miss any question on probability. This is the major headache for students, the ability to always bring out event spaces. Now, guys, give me the event space around these dice, 2 dice of less than 6. Less than 6. Oh yeah, I expect everybody to be able to flow with that. Less than 6. Guys, less than 6. Oh yeah, give me less than 6 quickly. We are running up the class very soon. The class is coming to an halt, to an end, anytime from now. But let's perfect the knowledge. Of course, tomorrow we'll be starting from packing cards. All right, packing cards. But let's be done with this aspect so that we can be very we can leave this out. Packing cards will be the first thing we'll be talking about tomorrow. Guys, bring out the event space for less than 6. Total score that produces numbers less than 6. So we have answers. Let me see the answers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Okay, this person gave me a number that has 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Praise, your number is 9. Precious gave me 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 also. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay. So can you those of you, can you just go on to give me the number of elements in your event space? Guys, those of you that give me, just count your event space and give me your answers. Number of elements in the event space. Okay, somebody wrote 10. Tawheed said 10. Foxy said 10. Precious said 10. Okay. Adewumi said 10. Praise said 10. Zeus said, sorry. Precious said 9. Zeus said 9. Victor said 10. Praise said 9. 10, 10. Many people are writing 10. 10, 10. Many people are writing 10. Now, again, this is an high hope now, of course, because I hope you know that in the end, if they're asking you to find probability, the most important aspect of the whole thing you did will be the number of elements. Now, I'm sure you can see from these two answers you guys are giving me, I can see both 9 and 10. I'm sure you can see that it's not possible for it to be 9 or 10. Sorry, 9 and 10. It's going to be 9 or 10. So obviously, if you're saying 10, of course, I believe you are the correct one. If you're saying 9, you have omitted 1, obviously. Scores less than what? Than 9, right? Scores less than 6. Less than 6. The total scores being less than 6. Let's try and bring them out. Less than 6. Less than 6. All these are not less than 6 now. So less than 6. We don't even have to do so much there because I know we have 1, 2. All these ones are going to be less than 6 apart from this. Less than 6, not including 6, by the way. Less than 6. So this is not one of it. This is also not one of it. This gave me 6 exactly. So 1, 2, 3, 4. This is less than 6. This is 5. This is 4, 3, 2. Less than 6. This is not included, obviously. We have, this is not included. This is where, so we have this, of course. Less than 6, we have these two. 1, 2, 3, 4, 5, 6, 7, 8, 9. So where did you guys get where did you get the last one? 1, 2, 3, 4, 5, 6, 7, 8. Where did you get the last one? Oh, 4, 1. Thank you very much. Yeah, thank you very much. Yeah, that's good. 4, 1. So you can see 4, 1 being there. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. I love that you guys are learning now. You can see how you are saying I did not include, I omitted. Now, in an example, you will not have the opportunity to obviously make amends. And that's why you have to be very, very exact. So be patient when solving questions around probability. Make sure you pay attention to all of the events. Because once you miss an event, if you wrote 9 out of 36 instead of 10 out of 36, there are two different answers when dealing with probability. All right. Now, let's see this last question under this aspect. Greater than or equals to 9. Greater than or equals to 9. Greater than or equals to 9. Don't worry, that guy is showing me the clock. I'm also watching the time. Greater than or equal to 9. Greater than or equal to 9. Can you give me the number, the event space of greater than or equals to 9? Give me the event space, then give me the number of elements of your event space. Greater than or equal to 9. Greater than or equal to 9. Greater than or equals to. That means you're dealing with greater than or equals to 9. That means you are permitted with including figures. This is inclusive of 9 and also greater than 9. The last one we said was less than 6. So we did not include 6. We did not say less than or equals to 6. So you need to be very careful with those terminologies. If I said less than 6, I did not include 6. That was why we did not include 1 and 5, 2 and 4 and the likes, because it was not inclusive of 6. If I said less than or equals to 6, then we would have included all those other ones. So in this case, now we're talking about greater than or equals to 9. So what is equals to 9 and greater than 9? Okay, you guys are saying number of elements is 10. Any other varying answer from 10? Any other answer other than 10? Okay, let me try and observe those. Greater than or equals to 9. Now I know already that all this, because the bigger numbers will be included. So 6 is included, 5 6 is included, 6 5 is included, 6 4 is greater than 9, 6 3 is equals to 9. It's included also because this is equal to 9. 5 4 is included. This is equals to 9, but it's included because 5 5, this is 10, is included because it is greater than 9. 6 4 is included, 4 5 is included, equals to 9. 3 6 is included, equals to 9, although not greater than 9, but equals to 9. Do we have any other one here that has not been included? This is 6 2 5. All these are going to give me 8. So I know already that you can see the pattern. So we have 1 2 3 4 5 6 7 8 9 10. So we have a total element of 10. All right. So if I'm asked to get the probability of picking a number, of throwing 2 dice up with the sum of their number, sum of their response being greater than or equals to 9, the answer to that will obviously be 10, of course, out of 36. We're going to get into so much of solving tomorrow. Today is just for establishing your knowledge around sample space and event space. And I should believe that we have been able to do a great job in establishing that knowledge. Will you guys agree with me that at this point, at the end of this class, you guys have been able to understand the real concept around sample space and event space? So just to sum this whole class up, we started with talking about probability. It has to do with chances. We talked about event space. We talked about sample space. We talked about 0 representing. Guys, let me quickly say one thing. Let me ask a question quickly. What did I say 0 represents when dealing with probability? Shoot me my answer. What does 0 represent? If you get an answer of 0, what does it mean in probability? What does 0 represent when dealing with probability? Okay, impossible. That means that's impossible. What does 1 represent? What does 1 represent? Okay, certain. Good. Certainty. 100% certain. So that's just all. Now, guys, tomorrow, same time, same venue, we're going to be dealing with cards. I need to explain everything around cards because I don't want you guys to, some of you are not very conversant with playing cards, so you may not understand, and those questions do come out in exams when they will ask you to give probabilities around playing cards. So we're going to talk about cards tomorrow and some other concepts around probability, combination of events, mutually exclusive events, independent events, and every other thing in between. So guys, this has been really great. I'm sure you guys enjoyed yourself this night. I love your responses, and I love the fact that you guys have really come to understand the concept, the introductory part of probability. So this is where we're going to stop for today. Of course, we're meeting tomorrow. And by the way, guys, don't forget something. By 9 a.m. tomorrow, 9 a.m., please check on the channel. You'll be solving your first test on probability. All right, 9 a.m. Please pass the message very far and wide. 9 a.m. tomorrow, you'll be solving your first quiz test. All right, make sure that you participate, and that will be a very great way of testing your understanding of tonight's class. So guys, thank you very much for joining. So good to be able to pass this knowledge to you. Thank you very much for joining up. We'll see each other tomorrow. Do take care of yourself. Enjoy the night rest. Bye-bye.